Okay, guys, if you haven't started looking at this first example, you need to go ahead and start looking at this first example. You may be able to do it. But, Chris, looking at this thing right here, what would you call it? What's the name of that thing, Chris? It is the difference of two squares. It is a difference, and that's a perfect square, and that's a perfect square. So, who can tell me what this factors to? I don't want to do that whole factoring thing. This is a quick one. Connor. Z and Z, right? Uh-huh. Minus 7 plus 7. Done. That's it. Okay? We don't want to take any more time factoring that than we need to. Okay? That thing's done. Let me go ahead and put some lines up here so I don't mess these things up. Okay, you should already be on the next one. Mark L. What do I get when I factor this thing? What do I call this thing, Mark? It's called the difference of two squares. And so, since it's the difference of two squares, what do I get? 4 minus 3x, and then 4 plus 3x. Exactly. Mark was saying that it's the square root of 16, which is 4, and the square root of 9x squared, which is 3x. So 4 minus 3x times 4 plus 3x. Done. That easy. Chase, what is this thing called? It's called the difference of two squares. So I know it factors into some binomials with a sum and difference pattern. What do I get here? 9a plus 5x to the third. Beautiful. 9a minus 5x to the third. Okay. Any questions on that? Connor, what you got back there? No, because Connor's question was, don't I get, when I multiply 5x to the third times 5x to the third, do I get 25x to the ninth? No, because I don't multiply exponents. I'm multiplying the base by adding the exponents. X cubed, you'll remember, x cubed times x cubed is equal to x to the 6, because I add exponents when I'm multiplying their bases. Okay? James R. Wait, you wrote problem B as, say again? 3x plus 4 and what? Negative 3x plus 4. You know what, James? I'm going to ask you to leave it like this with the 4's in the front. I know it's not standard form, but I want to keep that sum and difference pattern that way because I don't want, you'll see when we start working with rational expressions in the next unit, we want to make sure those things are in the same order so we can cancel them out. Okay? All right. Great job, guys, on example 1.